Hey, I'm Charlie Thompson, and this is the introduction for Chapter 2, Energy in the Atmosphere. There's a little person down there. That's Death Valley. I picked Death Valley because it's hot. Get it? Energy? So it's hot because it's Death Valley. So what are we going to talk about? How does energy move around? That's something I bet you never thought about a whole bunch. Where does the energy flow? You should know the answer to this. The spoiler, from the tropics towards the poles. What controls Earth's temperatures? You also know the answer to this because 95% of everything in this entire class is just latitude. What are Earth's temperature patterns? You also know that. The tropics are hot, the poles are cold. Tropics have a low range, the poles have a high range, latitude. So, too long, didn't read. We get energy from the sun, mostly light, with a little bit of heat and some UV. Some of that bounces out to space, gets reflected. Some of it gets absorbed by the atmosphere. Half of it makes it to the surface. It warms the atmosphere. Atmosphere warms the surface. Surface warms the atmosphere. Atmosphere warms the surface. Surface goes back out into space. That's it. We get light from the sun. It becomes heat. The heat goes out to space. We'll talk about how energy moves around, radiation, convection, conduction, and latent heat. One of my faves, latent heat. We'll talk a lot about that. We'll look at patterns of shortwave albedo, light that's reflected off of Earth's surface, and longwave heat going out, and why those patterns are different. That'll be fun. We'll talk about insolation and albedo, patterns of insolation, who gets the most energy, and albedo, scattering, what happens with light. So we've got scattering, we've got refraction or bending of light. We've got refraction making mirages. Albedo is light reflecting off of surfaces. High albedo, reflecting a lot of light. Low albedo, absorbing heat, or absorbing light rather. Some numbers for albedo. Earth's average is 31%. The moon's average is about 7%. The moon reflects about as much light as asphalt. That's fun. Snow and ice really good at reflecting light. Fresh snow can reflect 95% of the energy coming in. We'll talk about the greenhouse effect. There is no greenhouse effect. It doesn't act like a greenhouse. It just acts like a blanket. We'll talk about the role of clouds. Some clouds make it warmer. Some clouds make it cooler. We'll talk about the Earth-atmosphere energy balance. Like there's a surplus, more energy comes in than goes out. That's review. More energy is coming out than going in. So there's an overall pattern of an energy surplus in the poles and a surplus in the tropics and a deficit at the poles. We'll break down what happens to energy from the sun. 100, 31, 21, 45, 23, 8, 110, 96, 14, 69, 31. Boom! We'll talk about Earth's energy balance at the surface. We'll talk about latent heat and how you can use latent heat to calculate actual evapotranspiration. We'll talk about how temperature is measured, different scales, Kelvin, Fahrenheit, and Celsius. How temperatures are measured, skin temperature, different than air temperature. We'll talk about average temperature, temperature range, the role of latitude in average temperature and temperature range, the role of land-water heating differences, continentality, how far inland you are makes a huge difference. Ocean currents, warm or cold, affect temperatures on the land. Ocean temperatures again. Cities are hotter, they're dustier, they're rainier. We'll talk about urban environments. Urban environments. Urban environments. Ha! Non-urban environments. That doesn't look urban. Temperature patterns. Where is it hot? Where is it cold? Where is it hot? Where is it cold? Who has a large range? So this is the difference between summer and winter. And then we'll talk about wind chill, why it makes you feel chilly. Heat index, why it makes you feel sweaty. Heat waves. And that'll be it for the chapter. So, chapter 2, energy balance and global temperatures. It's a good one. Brought to you by Latitude.